Okay. So let me tell you how this feature helps. Tell me one thing. Let's say we have a PC1 and we have a PC2 and we have 1,000 more PCs. We have a firewall here. And all this traffic going through this firewall, let's say they are accessing one common application. Let me just give the name like Outlook. This is just one of the common application. Now, tell me one thing. When PC1 access this outlook.com, all the packet or the packet of PC1 will go through with you with the app ID or not? First answer this thing. Guys, because you know Outlook is a HTTPS website. So this particular packet from PC1 will go through this app ID, processing app ID engine, right? Now when PC2 will access the same application, this particular packet will also go, the packet from PC2 will also go through the app engine. When the remaining 100,000 people, they will access the Outlook application. So every user's traffic is going through the app engine again and again, right? For the same application. So what they used to do, because my firewall create a cache. So if one person has access that application, remain for the remaining people, because it has created the cache information, and now your app ID information they will get through the silo path itself. They don't need to forward the packet on app ID for the remaining particular peoples. So that is the benefit you will get. Vivek, like either you can use web browser or you can use mobile app. Always you are going to access the app server only in a backend. Okay, just remember, in a backend it is always a app server. Now, and after that, now this packet move further for the next check, which is a forwarding lookup. Forwarding lookup means now they do the lookup into your routing table. The main purpose of this forwarding lookup is to get the egress interface detail. Now they will try to get the egress interface detail. They will try to get the egress interface detail. Now let's try to understand this. So guys, there are two things. Do you guys have any idea about the PVR? What is the main purpose of policy based routing? Or PVF, policy based forwarding, because both are same? Anyone have any idea on these two things? This is the time. Liaquat, you know, like what is PVR or what is PVF, or anyone? Yeah, Liaquat, you have answered correctly. Like it's a source based routing or a decision making precedent over the static route. So PVR will take the precedent over all the route. It's not about the static route. So generally what used to happen, this PVR or PVF, what we will do, it's a policy based forwarding in Palo Alto Firewall. Means generally when any device doing the lookup into the routing table, when any device will do the lookup into the routing table, what they generally used to do, they used to do the routing lookup on the basis of destination IP address. Just remember, they will do the lookup on the basis of destination IP address, and they will try to get the egress interface. Okay, but what used to happen, let's suppose you have configured the PVF, policy based forwarding. In a policy based forwarding, this PVF will allow you to do the egress interface decision on the basis of defined rule set. If you have defined in the your rule, if traffic coming from this and going towards 8.8.8.8, this is a destination, and a port number, let's suppose like layer 3 protocol number is, let's suppose 6, or let's suppose destination port is 80. Just send this traffic through this interface, means we are defining the egress interface now. So guys, if we have a route, if we have a PVF, then what it will do, my firewall take the decision, or it will basically, it will get the egress interface details on the according to the policy based forwarding rule. If we don't have PVF, then it will do the egress interface decision on the basis of routing lookup. In forwarding, if you will see, to get the egress interface or zone detail on the virtual system, they will do the L3 route, means they will do the lookup on your L3 routing. For if we have deployed firewall in L2, then they will do the lookup into FDB lookup table, or they will do L2 FDB lookup. Okay, now let me just explain you this thing correctly here. So forwarding lookup, they generally do to get the egress interface and zone detail. For first packet, as per the interface type, the forwarding lookup stage determines packet forwarding path. Packet forwarding depends on the interface type. Let's suppose we have received the packet on layer 3 interface, then route table lookup is used to determine the next hop. If the same subnet, then ARP table lookup is used, means if the subnet is same. Means let's say source is 10.1.1.70 and destination is 10.1.1.80. Then they will do the lookup into the ARP table. So if we have a policy based forwarding rules and we have a fib, so generally guys, your routing table, we have a routing table. In actual, your firewall or any routing, any device, they will do the egress interface decision on the basis of fib, forwarding information base. Like in Cisco devices, we have a CEF table. So we have a fib table, forwarding information base, because in routing table, you have a multiple routes. Like you have a, maybe you have a route for same subnet, which is pointing towards two interfaces, right? But in fib, you have the actual interfaces defined. For layer 2, egress interface for destination MAC is retrieved from the MAC table. If information is not present, frame is flooded to all the interfaces except the interface in that particular VLAN. If we are having virtual wire, egress interface is peer interface configured in the virtual wire. No additional forwarding lookup is done. In tap mode, egress interface or zone is same. Ingress interface and zone packet is discarded. So guys, generally, now I think you have the clarity here. We do the routing lookup, we do the forwarding lookup to get the egress interface and egress zone details. If we have a policy based forwarding PVF, then they will make the decision on the basis of PVF. If we don't have PVF, then they will do the lookup into your fib table, forwarding information base. And let me show you what is fib table. If you will go here, if you run this command, show routing route, this is your routing table. This thing is known as a routing table. If you run this command, show routing fib, this is your fib table, and your actual decision is done by this particular table. Actual decision is done by the firewall by using this particular table, just remember. Okay. And after that, guys, once your routing lookup will complete, now your firewall, or before that, here we have to also discuss one more thing. Tell me one thing. Now they will do the net policy lookup. Here they will just do the net policy evaluation. Here they just try to do the net policy evaluation lookup, but they will just do the evaluation means what? They will try to identify this is my net rule. Okay. They just get that detail. This is my net rule like index 1, index 2. This is the net rule which I am going to use according to the net rule configuration. So guys, what happens? Let's suppose if your traffic is matching the destination net. So what will happen? Let's suppose my destination is this 10.1.1.70 is my source IP address, and my destination IP address, let's suppose 151.7.250. This is my destination IP address. When if there is any destination match happens, what will happen? This IP address will change or not? Guys, your destination IP address will change or not? What do you think? Right, when my firewall do the destination net translation, your destination IP will change. If your destination IP will change, then what will happen? Because here when we did the lookup in your forwarding table, we get the egress interface like Ethernet 1 by 1 is the egress interface that time. That interface we will get during the routing lookup, and that lookup we will did on the basis of destination IP, right? But now destination is changing because destination net match happened here. What it will do, if your destination if there is a destination net, yes, then I will send that packet again for the routing lookup, and this time my PAN-OS do the lookup on the basis of new destination IP address on which that IP address got translated. Because maybe for the new destination, maybe that new destination is available behind any interface, right? It can available behind any interface. So they will do the again, it will do the lookup into the routing table. In case of destination net, just remember. And after that, they move further. And let's suppose if there is no destination net, if it's just a source net, and if it's just a source net, then your packet just move further right away. Net policy lookup, if destination net is present on the match rule, do the second forwarding lookup to get the final egress interface. If it's just a source node, they will move further for the next check. Now let's try to see what is the next check. Now the next check is your authentication policies. Authentication policy lookup. But let's suppose you have configured the captive portal. Captive portal thing we used to configure for the contractor type of user. So before they will able to access anything through your network or through your firewall, they just validate their identities. So what if you have configured the captive portal? What will happen? These authentication policy will trigger. And guys, all these policies are here. If you will go into the policy tab, these are the authentication policies here. Right now, I don't have any, but from here, they will trigger this particular thing. Your PBF is also here. Your PBF will trigger from here. Okay. Now, and once your authentication policy, if we have configured, then only they will trigger. If no, then your check move towards the next thing. PAN-OS will start checking next thing, which is DOS protection policy lookup. Here they will do the lookup for the DOS policies. And when they will do the lookup for DOS policy, they will use the pre-net IP address and post-net zone. And so the guys, there is a concept of pre-net IP and services, and there's a concept of post net zone, and that thing I'm going to explain in your net session. Okay, so for now you can think about it like they will check your DOS protection policies, and if we have any DOS protection policy, like if we have configured any DOS policies, it will try to enforce these policies. DOS policies is almost similar to your zone protection, guys. Okay, and after that it will move towards the next thing. Like in DOS policy we have a two type of policy generally: aggregate policies and classified. Aggregate or classified threshold. If yes, like if any traffic matching the DOS policy, if there is a violation, then it will basically block it. If no, now your packet move further and they will basically check the security policy lookup, or they will do the security policy lookup. Now in this security policy lookup, what they will check, they generally use the pre-net IP address and port numbers and post-net zone. Pre-net IP address means your, or how I can explain this, but like, because you know this pre-net concept you will get when I will discuss the, when I am going to discuss the DNet. Okay, so the thing is, uses pre-net IP and port numbers, post-net zone details. They will think application as any, URL filtering category as any, and then they will start parsing the rules, and they will start looking the rules. And guys, the rules lookup start from top to bottom. Means whatever rules you have on the top in your Palo Alto, these rules got processed first, then it will do the lookup towards bottom. If you will go here into security policies, they will start the security policy evaluation from top to bottom. They will check first rule. If match happens, then they will stop checking. Then they will move. If match is not happen, then this one, then this one, this, like that. They will move further. That's how they used to basically do the this particular thing. Okay, security policy lookup. I got lots of, like, I got question on two people. How do you guys digest? It's up to you guys. If you will not able to digest, you can skip, right? Because you know, I'm explaining step by step and you guys needs to digest. That's how you will able to crack the interview, right? Now, if guys your traffic is matching any rule, and let's suppose on that rule, if we have set the action deny, in that case that packet is discarded. And guys, if your security policy is discarding any packet, you will get that detail into the log, into the monitor tab of your Palo Alto Firewall. So your log will be generated, and this log will only be generated if you configure log at the session start or log at the session end on that particular rule. Otherwise it will not generate any logs. So guys, if like you are not able to get the information on the log, you don't need to say, like, you don't need to say to your customer there is no issue on the firewall. Maybe your maybe the packet is dropped at the ingress stage, maybe packet is dropped by the zone protection, DOS policies, routing, multiple things are there, right? And if let's suppose your security policy action is allow, then what will happen now? Palo Alto Firewall create a session and it will install the session into the session table. And here guys, what? Here it will create a session, it will install the session into the session table. It will create client to server flow and server to client flow. And it will store that information into the session table. Because you know, in Palo Alto Firewall, all it has a capacity, let's suppose your fire device has a capacity of 64,000 sessions. So because you know, all these session IDs generally available into the free pool. All the session ID is a part of free pool. And if your firewall is allowed the traffic, then what will happen? One of the session ID, your pen will take out from that free pool, it will allocate that session ID. Let's say session ID 100 is allocated, and with this session ID 100, client to server and server to client, these two particular flow key is associated. Because this client to server, all that information we will extract it into ingress stage, right? For server to client only, we were not aware about the zone details. And because by looking into the routing table, we have the zone details, so we have all the information to create both the flows, server to client and client to server, and they will install that particular session. And if once this session is created and installed into the session table, now they will basically check the tunnel inspection policies or your TCI policies. Because nowadays, if you will see, there are some application who is supporting the layer 4, like 4-layer encapsulation or 7-layer encapsulation, right? Means we have a actual header is hidden inside 7 layers of any other headers, right? So all these things they will basically parallel to get from the TCI policies, tunnel inspection policies, like protocol like GRE, GTPU, IPsec, non-encryption, VXLAN, all of them, TCI related policies. And after that, guys, what will happen? Now till this point, your silo path has been completed. Once your silo path is completed, if I'll go here now what used to happen, if you will go, your session is created and installed into the session table. And after that, you can see this pointer came into the layer 2 to layer 4 packet processing or firewall processing. Okay, so one session is installed into the session table. Flow session is in session table. Now what here also they will verify. If that session ID is in free state, then they will discard. If session stage is opening, discard, or active, they will reset the default timeout for like TCP, UDP, and ICMP. And what they will basically put that particular, and after that your cursor move towards the fast path, which is also known as security processing or layer 2 to layer 4 security processing. Now in this layer 2 to layer 4 security processing, what they will do, they will apply the net. So guys, in the silo path, only net evaluation happens. Actual IP translation they will apply here. Apply net if applicable. And again, they will do the forwarding lookup for all client to server and server to client packet. Now, why they are doing the lookup again? They used to do the lookup because when reply will come from that server, how my firewall know where he has to send that reply? For reply packet, they will do the forwarding lookup. There's no route, then that session will be discarded right away. And after that, that packet move here for the SSL proxy. Generally, if your firewall is doing if we have configured the SSL proxy, so with each and every session, there is a one flag which is associated for SSL proxy. So if SSL proxy flag is in session, if yes, then apply the decryption if applicable. And SSL decryption, this thing is applied when we will configure. Okay. And after that, it will move further. Application identification in the session. Mean now they will, if if my PAN-OS know the application of the session. If no, if yes, if my firewall know the application, then it will move for your layer 7 inspection for content engine. If my firewall don't know the application, now it will send this packet through the app ID. In app ID, this is the app ID related information. In app ID, what? They will check the application override policies. There are the application override policies, and we can able to configure these policies to bypass the app engine for some internal applications. Okay. So if your application is a part, if like we have configured the things, whatever like app override policy we are having, if this policy is matching, then your PAN is reached here, like enforce the security policy with that application. Security policy lookup with that application, they will check rule match action. If action is allow, yes, then security profile configured. If yes, then they will send the packet towards the content engine. If no, like rule, like if we have a application based rule, then that packet got discarded right away if the action is denied. If your traffic is not a part of app override, then move further and it will do the pattern based application identification. And here your actual app identification happen, means pattern based application identification will happen. And if application is identified, they will update the application cache. Then they will enforce the security policies for that particular application. Now go a little bit here. Now your if layers and like apply security profile flag on the session. So what do you has to happen, like if on your security policy, if we have enabled the layer 7 security profile, if that profile is enabled, then only your packet will go inside the content engine, and that particular flag used to add with that particular session. Okay. And after that, they will also check the quality of service QoS policy lookup. And also one more thing, guys, let's suppose if your application is identified as SSL, secure socket layer, or SHS. If yes, if your application identified as a SSL or secure, say if yes, then they will forward towards the decryption policy lookup. Now they will check the decryption policy, because we were only able to decrypt the traffic for SSL and SHS protocol. If decryption rule is matching, like match decryption exclusion cache. So guys, there is just one exclusion cache, like we can able to exclude some traffic from the SSL decryption. If yes, then this packet go towards the layer 7. If no, now this particular packet again go into your fast path for the SSL related SSL decryption related things. Okay. Now we have a content engine here, CTD. This is your content ID, your URL filtering, antivirus, all these things applied here. So like if CTD flag or layer 7 enabled in the session, then they will move further. And here what they are running some type of decoders and other things. They have some application decoders here, because tell me one thing, let's suppose I have identified application as Facebook base, and now on my session they have written this particular traffic belongs to Facebook base. So guys, if application is identified as Facebook base, do I send that packet again or the remaining traffic again through the app engine? No, right? Because application is already identified. Now let's suppose suddenly there is a person who will start using the Facebook chat. So how this application shift will detect by the firewall? It will detect with the help of these particular decoders. Application shift yes, then this packet go in the app ID again. If no, then threat detected. Threat means if your traffic having any type of malware. If threat detected yes, Then apply the security profile action. So if we have action like drop, reset client, reset server, reset both, then they will discard. If we have action like alert or allow, in that case, they will allow the traffic. If threat is not detected, they will send packet here. And if we have applied the SSL decryption, if your SSL decryption is applied, we have to re-encrypt the traffic. What we will do the re-encryption of the traffic, and after that we will forward this packet towards the packet forwarding stage. So this is the egress of forwarding stage. Now in the packet forwarding process stage, use the ingress interface to get the forwarding domain, do route, do switch. What, like if we are having like, it's if we have received the traffic on layer 3 interface, then we will do the route lookup and your ARP look and L3 lookup and your L2 lookup. We will create a new IP header. We will form all the packet and everything, and after that we will forward. If let's suppose we have deployed firewall in vwire mode, then they will send out the packet through the another interface. And if like packet egress processing, apply the defragmentation if needed, apply the quality of shaping. If we have configured QS, then they will basically apply the QS shaping if we have configured. Ingress to the tunnel interface. If your egress interface is the tunnel, then if it's a IPsec VPN related traffic, then they will do the encryption, they will calculate the hash, and they will encapsulate. For SSL VPN encrypted, has added. For GRE has added and encapsulated. And after that only they will forward this packet through the egress interface. So that's how the packet flow of your Palo Alto firewall. Like in app ID, as I have mentioned, check the app override policy, do the pattern based application identification, enforce the security policies for that application. If rule match, if action is allowed, yes, then move further. If no, then discard it. Now they will check for the content inspection setup, application SSL and decryption policy match. If yes, then forward this packet again into the fast path for the SSL decryption related things. And when your packet reached here into the content engine, they will do the scan, they will check, they will run the procode parsing, decoding, content matching, all of them. Application change from the content inspection. If yes, means if there is any application shift, they will send the packet again into app ID. If no, detection result from the inspection, apply the security profile action, apply the decryption if needed, and they will do the packet forwarding like that. Now, let me show you same thing, guys. Let me just also check one more time if I have anything here as well. In fast pass. So guys, if you can, what you need to do, you have to check this particular document. Just go through with this document. Here I have written all the step-by-step process. Okay, all the step-by-step process is there. I'll put that particular document with everyone. Okay, don't worry. I'll share maybe after today's class. Now, let me do one thing. Even though this document is also very good, I have found this document will also have the information. The main problem with this document, because this is an official document from Palo Alto, and I think it's a very old one. I can see the date and other things as well. Like they have done the revision on 2005. Okay, cool. Now, just guys, give me 1 second. Only 1 second I need. Okay, cool. I hope guys I'm audible properly. Just confirm yes, no on the chat. Let me just go through with that part and this one. So guys, if well, actually, as you know, as I have told you, your TCP SYN processing used to happen like ingress stage, flow lookup, slow path, fast path, forwarding stage. Now, if you go here into this particular, because this is the actual packet processing, packet we have received at the ingress stage, it's just a SYN packet, right? You can see it's a SYN packet. For SYN, we don't have any type of active flow in the flow table. So it will go into your silo path. In silo path, basically, it has used all that particular information. 1 minute. It will use all that particular information which it has extracted. Now, session setup, it will do the PVF lookup if there is any. It will do the net policy lookup, DOS policy lookup, TCI inspection, allocated new session ID. This is how it will do the allocation, right? Net rule, which net rule it is matching. It will make the, it will just put that detail here, right? It will put the index detail because you know every net rule they have the index. If you run this command, set CLI config output format set configure. So running. So rule set. Exit. So running net policy. You can see these are the net rule and every net rule had this index number, right? So they will just write this index number, which net rule they are matching. Okay. That's the evaluation process. They have this index number and other things here. And after that, this is how they used to do the translation. So they will put the source translation detail as well. Then created session, in queue to install the session into the session table. And after that, your packet go into the first path. This is the guys actual how like TCP three-way handshake happens, because here I have written TCP SYN packet processing. Now your packet reach into the first path. IP checksum valid, net session. Here it is just running the address translation, port translation. Pan flow process first path. Now your packet is going into the first path. It did like L3 mode, router is this. This is the forwarding lookup. This is the egress interface, port ID, route lookup, route found, right? All these things, ARP lookup it has done, and translate the packet on the port ID, which is 16. And this is how it will do the processing for TCP SYN plus ACK. Ingress stays. This time there is active flow in queue to first path, and your packet is directly going to the first path. It is bypassing the silo path, right? So we have proved that if there is a session, then it will always go into the first path, and it is going, right? You can see. And how you will validate? We are looking the correct information. There is a way. Let me just do Control C, Control A. Let me go here. TCP SYN packet processing. Then we have a ACK packet, because you know if you will highlight this sequence number, because sequence number is similar for entire packet, and this is the same sequence number. This packet go directly from ingress stage, because you know this is ingress stage. It is going towards the first path. Then your forwarding. Here your ingress stage. This is ACK packet. Then your first path and your forwarding. Then client hello. your ingress stays, your fast path, and now you can see it is going inside the packet 9 packets resequence. Right now it is going towards the SSL engine and other things. You can see now it is sending that packet through the pen URL cache and all these things. These are the app ID and content ID related information. And after that, we have received the packet into the forwarding stage. Then these are the URL filtering logs. How the Palo Alto Firewall going to do the URL filtering, everything is there. Okay. So that's how your packet processing used to happen in your Palo Alto Firewall, guys. So guys, I think now everyone able to understand this part, right? How when there is a communication between this PC and this firewall and this server is happening, how the traffic flow and how the things are happening. Let me just explain you with the help of one more diagram, guys, so you at least got everything, because you know my main intention is to explain you all the things here. Let me just tell you again the same thing. In ingress state, we used to receive the packet. It will detect and drop the packets with the errors, detect and block the pre-session packet based on the, if there is any attack is happening, they will block these type of packets as well with the help of DOS block table and all. Then we have a silo path. They will in silo path generally what they will do the zone protection profile check. Then they will do the lookup into your app ID cache. Then your user to IP cache. And after that, they will do the lookup into the routing table, then net table, right? And after that, you can mention like user-based policies, then DOS policies, or user or authentication policy, then your security policy, and after that, your TCI policy, tunnel inspection policies. Then we have fast path. They will perform the net and decryption, perform session-based DOS protection, check and apply the security policy rule. Then app ID, they will try to do the application identification, content inspection. They will scan the layer 7 data for any type of threats, any type of malwares, any type of like antivirus and any type of virus and other things. Egress, they will apply the quality of service QS thing, and they will send out that packet through the egress interface. Now, in this diagram, you will see in ingress stage generally they will do the error check, source interface and source zone lookup, and BPN decryption if we are receiving the BPN packet. In firewall session setup silo path, they will do the routing lookup to get the egress interface and egress zone. They will evaluate the net policies. They will basically enforce the user ID based policies and user to IP map policies. They enforce the security policies. They enforce your DOS policies, right? They will also enforce your tunnel inspection policy like TCI policies. For existing session, it will go into the fast path, layer 2 to layer 4 firewall processing, and SHS proxy decryption. If there is a web convey SSL decryption, then your decryption will kick in here. Then app ID, your app override policy, your payload inspect, enforce the security policies again for the application. Then content ID, apply security profile, and do the SSL re-encryption if we have did the SSL decryption. Then forwarding stage, keyword shaping, VPN re-encrypt, and net applied. Generally, this is wrong. They will do the net application here because you know I get this particular packet flow detail from one of the internet diagrams, so maybe information not correct. Then let's see what is the third thing we are having. If you will see this thing, you will get the same detail. We have received the packet, extract layer 2, layer 3, layer 4 information, do the error check, get the ingress interface and ingress zone detail, right? We will perform the DOS block table check. We will do the error check. For IPsec SSL VPN lit traffic, we will apply the decryption. We will send the actual IP header again for the ingress check, and we will send this packet for the session matching. And they will try to match the session on the basis of unique 6 tuples: your source IP, destination IP, source port, destination port, your protocol number, and your ingress zone. And we have a 2 unidirectional flows, one from client to server and another one from server to client. If there is an existing session, if yes, then fast path. If there is no existing session, then slow path. And these are the 6 tuples compared to the table of the active flows. Just remember. And how we will do the how we will check what information be in your session table. This is the command: show session all. And right now I have, these are the sessions right now I have on my system. This is your ingress stage, guys. Now we have a slow path. Let me just explain the slow path again. In slow path, the very first check is your DOS protection profile and TCP state check, right? And after that, because you know some information are missing here as well. And after that, what we have here, if you will go, after that we have a user to IP cache, then app ID application based cache, right? This is the thing which they will do. Now they have a app ID, application ID cache, and your user to IP mapping cache. Then your routing lookup. In routing, we have two things: PVF, policy based forwarding, or your fifth table forwarding information. If PVF is there, then this will bypass. If PVF is not there, then they will get the egress interface on the basis of fifth table. Then for the net policies, they do the lookup on the basis of destination net. If there is a destination net, yes, then they will do the secondary lookup into your forwarding table again. If no, then they will enforce here your authentication policies. Then your DOS policies, whatever DOS policy you are having. Then your security policy evaluation will start. And if your security policy is allowing the traffic, if yes, then they will create a session and they will install that particular session into the session table. And guys, this information is wrong. Your DOS policy evaluation happens before the security policy, just remember. And after that, we have a where is that silo path and silo path connection setup. Then we was this is the like in with silo path versus fast path. Escape this particular silo path if there is a session is already there. For packet is an established session, means if there is a session is already established for a packet, then it will always go into the fast path. And this silo path will be bypassed if there is a session is already there on the session table. If no, there's no session, then your packet go into your silo path. Forwarding lookup used to happen, your net policy, your firewall security policies, all these are the things which happens here. Layer 2 to layer 4 firewall processing, do the net if applicable, apply the SSL decryption if needed. Now go here. So like it's same thing, layer 2 to layer 4 packet process, firewall packet processing, apply net, apply the SSL decryption needed. If has app or content ID change, if yes, then go for app ID, go for content ID. If we have not configured these things right, let's say we have not configured any type of layer 7 profile, then it will go directly towards the forwarding stage. Then we can go here. Let's see in app ID what are the things is happening. Mayur, it's a very good question which you have asked, like why there is there's a net in twice in slow path and fast. It's a very good question, and I was expecting that question from one of you. And let me just explain you that question, and after that I'll go into the app ID. So guys, if you have seen in slow path, as I have mentioned, they do the net evaluation. And fast path, they generally apply the net. Means here they will do the net translation. Now tell me one thing. We have this PC, we have this particular firewall, and we have this server. And we have configured the net here. Net is there. And we have, let's say we have configured the source net. And let's suppose on this server, I'm trying to download a 2 GB of file. So he will send the packet like this. This is the first packet. This is the reply of the first packet, right? Then we have a second packet. Now tell me one thing, Mayur, is the second packet go through your silo path? No. Now I hope you got the answer. Why we are applying the net in first path? Because subsequent request and reply packet we will not send through the slow path. So that is the main reason we have to apply the net on fast path, because without applying the net, your things will not work, right? So that's the concept behind that. Okay, I hope you got it now. It was a very nice question actually. It's a nice catch as well actually. No. In app ID, as I have mentioned, they will check the app override policies. Then they will do the app identification on the basis of pattern based application. Then they will enforce the security policies for that application. If there is any type of layers and profile is there on your security policies, they will basically add that particular thing there. Like we have to send this packet for the layers inspection, means we have to send this packet towards the content engine. Set QoS. If there is any decryption is applied, we have to do the re-encryption and other things, but generally this re-encrypt we will do in the content ID. Okay. If there is no content ID, then we will do the re-encryption here as well. And after that, we have this one, which is a forwarding stage. Packet forwarding, BPN, QoS, all these things they will apply and they will forward. Net, they will never apply here. This is wrong. This also they don't check now here at the end. This is the land attack. Source equals to destination. These things they generally check at the starting only. So guys, that's how the packet flow. That's how the Palo Alto Firewall going to do the packet processing. Now there is a one topic left from yesterday, which is that is the one initial access. How you will get the initial access basically of your device. Let's try to understand that part. So for this initial access, I will use, there is a one diagram I was having of firewall. Now, guys, tell me one thing. Let's suppose you have received this particular device in your environment. Now your manager came and he just asked, can you just start configuring this particular box? What you will do generally? What is the process followed by the organization? Let's suppose you got a new box. Now you have to do the implementation of that box. What you will do? What is the first activity? You will basically identify the rack and you will identify the rack and server room where you have to put. You will identify all the cabling. You will identify the cabling is there or not. You will also identify the distance between this particular firewall and your core switch and your ISP routers. When everything you will arrange, what? You will do the rack and stack. You will do the rack mounting of this particular box. And after that, once you get the rack mounting, the fourth thing, what? Now you have to get the access of this box. Now how you will get the access of this particular firewall? So for getting the access, guys, in this firewall, if you will able to see, we have this particular port, console port. So we can basically access this firewall with that with the help of this particular port. We can get the console access. And what we used to do, because you know all the management related stuff we used to perform with the help of management port on this particular device. And this device has a dedicated management port, which is this one. So what, once we will get the console access of the firewall, what? Because you know in this console there is a one password is configured. So the default username for Palo Alto is admin and default password for Palo Alto is also admin. And even though in your management interface you have a one default IP address 192.168.1.1. Now after entering these details, what? You will get the console access of this device and you will start doing the management interface configuration. In this management interface, what? You will configure the IP address and net mask. You will configure the default gateway. You will configure the NTP server detail. You will configure the DNS detail and you will configure the host name detail. You will configure the login banner. You will also do the configuration for time zone. These are the basic configuration you need to do with regards to this management interface. And if you will able to configure all of them, what you will do? And you will connect this management port of this particular one of the switch where you have a definitely you have a one management VLAN. Let's suppose in your case you have a management VLAN like 999 or 777. These are the some names or some format used by the organization. So you will put that particular port of switch like let's say FY0 on this particular management VLAN, and after that you will access this device from any type of jump host in your production environment or any type of like static environments like or any jump server from where you are accessing the other networking devices. So that's how the process used to happen with regards to the initial access. We also have some more point on the initial access. Let me just cover that as well. Let me go a little bit down. So generally for initial access, first time we used to get the console access, and after that We will do the configuration in the management port. We will do the cabling of your management port, and we will able to access the firewall through the management interface of, or we can able to access this firewall through the management port. And guys, by default, username to log in into your firewall is admin. When you will log in into the console, password is also admin. Generally, there is a one default IP address is also configured in your management port on the hardware boxes. 192.168.1 in virtual boxes, DSCP client option is there. Means these devices, they will get the IP address from DSCP server if you are running. And guys, your Palo Alto device, it has a dedicated out of band management interface. It's just a normal Ethernet interface, it's just a normal copper port. It's not a fiber port, just remember. It's just a normal 1 gig of copper port. It's a out of band. Sometime you will see OBB, out of band management. These are the terms used by the peoples. And guys, by default in this management port, SHS, HTTPS, and ping, these three services are enabled. Means you can able to do the SHS on the management port of the firewall. You can able to access the firewall with the help of HTTPS, and you can able to get the, you can also able to do the ping. You can able to ping that particular IP address of the firewall. So Maninder, I was talking about the management port. Management port of your Palo Alto firewall. VM is by default has a DSCP client option configured. Means if you have any type of DSCP server here, and so the thing is, as soon as you will connect the cable in the management port of the Palo Alto firewall, it will start sending the discover message. And discover message to DSCP. This DSCP will provide one of the IP address. But the best way, always connect with the console port and configure the static IP address there, because we always configure the static IP on the management port. Now guys, tell me one thing. Generally, why we have a dedicated out of band management? Why we have a dedicated management port? What is the benefit we will get with the, if we have a dedicated management port? And what type of traffic we will be expecting on this management port? So guys, the main benefit, we will get this traffic segregation, and we will only send the management related traffic. Like what is the management interface traffic? We have a traffic like we want to take the SHS access of the device. We want to take the HTTPS of a device, because all the configuration related traffic will go through with SHS or HTTPS. Let's suppose if you want to fetch any type of SNMP related information, all your SNMP polling is happening through the management interface. Let's suppose your firewall is needs to do any type of DNS related thing, like it, let's say it needs to do some name to IP resolution. Your DNS traffic will be sent through the management interface always by default, but you can able to modify. Your NTP related traffic will send through the management interface. All type of signature updates, for your applications, your antivirus signatures, your anti-spyware signatures, your vulnerability signature, all these signatures, my firewall will download from the updates.paloaltonetworks.com with the help of through the management port only. If you are using firewall, if you are managing firewall with the Panorama, then your Panorama, whatever the communication is happening between firewall and Panorama, they will use the management port for that. If you have configured the syslog, your syslog related traffic will go through with the management. If you have configured the user to IP mapping like user ID, then all this user ID related traffic will go through the management interface. So that is the main benefit we will be having, because we are not mixing the users traffic and your management traffic. And this is the few points which I have written with regards to the management traffic. Let's suppose you have any type of, if you have any type of backup server and you are taking the config backup, that backup server traffic will also happen through the management interface only. Let's suppose you have configured the net flow. The net flow related traffic also you can send through the management port only towards your solar window net flow analyzer. Mubarak, how you can say like update packet is a update traffic is very high? These are the just updates like 10 MB of updates, 20 MB of updates actually. Okay. It's not like updates like we have a 1 gig of updates and all. No, it's not like that. So like net flow traffic, you can able to also send through the management interface. And I've always recommend you can send this traffic through the management interface only. Not needed, you can forward through the data port, not required at all. Okay. And like what if you have configured any type of like email polling and other things, any type of alarm and other thing, that traffic also you can able to send. So let me tell you what type of traffic generally we will forward through the management port. You can go into the service route configuration, customized, like autofocus, CRL status, data services, DNS, panorama, post update, DNS, EDL, email, HTTP, IoT, Kerberos, LDAP, right? They will use by default management port. Your multi-factor authentication, your net flow, Mubarak, so net flow is also, they will forward through the management interface, okay, by default. But you can able to modify your NTP, Palo Alto Network Services, Panorama Proxy, Radius, SCAP, SNMP Trap, Syslog, TechX, User ID Agent, URL updates, VM Monitor, Wildfire, and JetTP. All that traffic they will send through the management interface. Okay, just remember. Now, go here. Let me just see. Okay, guys. So let me just also cover that point as well, because this point is also important. When you have the firewall, generally we can able to control the firewall. We can take the web interface access, or we can take the GUI access of the firewall. By using the HTTPS, we will put HTTPS:// and the IP address of the firewall, and we will get the access via GUI. We can able to also get the access via SHS, via console cable, even though you can also allow to enable the telnet if you want, but telnet is not recommended to allow in the production firewall. You can here, or you can also able to allow HTTP, but not needed. So GUI access we will get from the HTTPS, CLI access we can get from the SHS or console cable. We can also control the firewall. We can do the firewall administration with the help of Panorama. And the most important thing, we can control the firewall with the help of REST API or XML API, means with the help of automation. Like we can able to do the automation with the help of Ansible, Python, right? For that, they are using REST APIs or XML APIs. So these are the 4 ways to do the administration or to do the configuration in your Palo Alto Firewall. Web interface, Panorama, CLI, and your XML or REST APIs. When you will do when you will log in first time into your firewall, it will basically give you this warning to change your old password, and your old password is a admin one. Just remember, and that password has some complexity, like it is 8 character long, one uppercase, one lowercase, one numeric or special characters. So we will see all these things. how the management interface we can configure, so we can do like that. And remaining thing I will cover later, guys, because you know this updates and other thing is a part of your next session. Like I will cover your dynamic updates and other things here. So like in your next class, I will try to basically help you with the lab setup. So we will build your lab on VMware workstation, on your EVNG, and also on your Google Cloud platforms. Okay, so from next lecture onward, I will do the lab setup and other things, guys. And today, so I'm stopping here like around 30 minutes before, because we have already completed the topic which I wanted to cover with regards to today's session. And remaining thing we will discuss in your next class.